Lesson 14, I will define and construct triangles from given criteria. In Lesson 13, we learned to sort triangles based on the length of their sides or based on their angle measurements. Well, today we're going to actually construct triangles, which means we're actually going to draw triangles based on given criteria. So once you get your problem set, you're also going to need a protractor. Now I want you to notice that the directions say draw triangles that fit the following classifications. Use a ruler and a protractor. Label the side lengths. So for A, it says that we need a right triangle and an isosceles triangle. It has to be the same triangle. It has to be right, and it also has to be isosceles. So we have to think back to yesterday. A right triangle refers to what kind of angles it has. So if you remember, a right triangle has one right angle and two acute angles. Do you remember what an isosceles triangle has? It doesn't have anything to do with its angles, it has to do with its sides. It has to do with having two equal sides. So, whenever you are drawing a triangle and you have to base it on its angles and on its sides, you have to do the angles first. So that's why I have my protractor right here. All right, so the first thing we're going to do is we're going to create a right angle. It doesn't matter where you put your right angle, but I'm just going to put it right here at the bottom. So remember how you draw an angle. You're going to take your protractor and you're going to use it as a straight edge, and you're going to use your pencil to just create a base for your triangle. Then you're going to take your pencil and you're going to put a mark at the 90 degrees. So if this is 90 degrees, put your mark here, and then you're going to turn your protractor sideways, just like this, so that you can use it as a straight edge. And then you're going to connect the vertex of your triangle. I'm having a hard time getting that straight. You're going to connect the vertex of your triangle to this point. And then you should have a 90-degree angle. And we'll go back and double check and make sure that it is 90 degrees. It may not be perfect, but as long as it's close, we'll call it good. Okay? All right, so let's check and see if this is 90 degrees. It definitely looks 90 degrees. Let's go ahead and see. So now, no matter what I do to this, it will definitely be a right triangle. But I have to make sure that it's isosceles. Well, because of this right triangle, there's no way that this can be equal to this and be different from this. These two parts of the triangle have to be the same length. So this is where you're going to need your ruler. You will need a ruler for this. So what I have here is a metric ruler. It's not labeled, but these are actually centimeters. I like to use centimeters whenever I am measuring something small because it's easier to measure small things with centimeters than it is inches because inches are larger. It doesn't matter if you use centimeters or if you use inches. Now I will tell you that this ruler is not to scale, okay? I want you to take your ruler, and I'm going to make mine 3 centimeters on this side. So I'm going to, you might have to use your pencil to erase. You know what, it might be easier, since this one's longer than this one, it might be easier just to measure the long one and see how long it is first. Let's measure this one first. Okay, so this one is almost 4 centimeters. So let's just make this one a little bit longer so that it's 4 centimeters. That's not a very nice straight line, is it? All right, so then let's take this one, we'll make this one 4 centimeters. So we're going to extend this one. That looks better. All right, so now I've got 4 centimeters, 4 centimeters. Now all I have to do is connect these two, and I should have an isosceles right triangle. Okay, so I'm going to go ahead and label this. So remember what you do if you have two sides that are the same length. You take and put a tick mark on the two sides that are the same length. So this side is the same as this side. And I'm going to go ahead and put this right triangle mark here to show that that is a right triangle. Okay? All right, so basically that's what we're going to do on the whole front side of this sheet today. We're going to draw triangles that have 2 different criteria. It's going to tell us what to do with the angles and also the sides. All right, so now for B, we're going to make an obtuse and scalene triangle. So remember, an obtuse triangle has one obtuse angle and two acute angles. And do you remember what scalene means? Scalene means that it has no equal sides. So let's begin with our obtuse angle. So we're going to use that same strategy as we used before. We're going to put up our protractor, and then we're going to use it as a straight edge. So I'm going to make sure that I have plenty of room, because when I make this obtuse angle, it's going to come back this way. So I want to make sure that the base of my triangle isn't way over here. I'm going to start it about here, and here is the base of my triangle. I'm not going to make it too long. And then I'm going to make an obtuse angle. It can be, as long as it's greater than 92 degrees, it's obtuse. But I think I'm going to go ahead and make mine about 150 degrees. So I'm going to put a mark here. And I want you to use your protractor as a straight edge, but I'm not going to do that just because it takes too long to turn that all around and get it back the right way. All right, so take your protractor and draw a straight line from the vertex to your point here. So now we have an obtuse angle. And now all we have to do is connect these two. I'm pretty sure that these two are not the same length, and I can already tell that this is going to be way longer. Now all we have to do is just measure to make sure that all three of these sides are not the same length. All right, so let's get our ruler. And this is about 2.5 centimeters. This is about 3, almost 4 centimeters. And then let's measure the other one up here. It's hard to get this straight on a computer. It's so much easier on paper. All right, and this is 6 centimeters. So yes, because none of the sides are the same length, it is a scalene triangle. And because this angle is obtuse and these are acute, it is an obtuse angle triangle. All right, now this time we're going to do acute and scalene. So remember, an acute triangle has 3 acute angles, but it has to be scalene. So that means that we don't want all of our angles to be the same. So in a equilateral triangle, if you will remember, the acute angles are all 60 degrees. So I want to make sure that when I make my angles today, that I don't make them 60 degrees. Okay, so I'm going to make my baseline a little bit in the middle this time. I'm going to scooch my protractor over. Okay, so I don't want it to be 60 degrees. I want it to be a little bit more than 60 degrees. So I'm going to make this one about 70 degrees. Okay, and now let's draw a straight line to connect these. Since this is scalene, it kind of is a lot easier to draw because they don't have to all be the same length. Because right now, these don't look the same length. They look close, but they don't look the exact same length. So let's get our ruler and let's measure and see. Okay, so this one is exactly 3.4 centimeters. If I count over the tick marks, 1, 2, 3, 4. So this is 3.4 centimeters. And then let's see how long this one is. This one is 3.5. Ooh, it's close, but it's not exactly the same. So it technically would be scalene, but they are definitely close. This side looks a little bit longer. Okay, this is almost 4 centimeters. So it is scalene, even though really and truly these two sides over here are really probably very close. So I probably could have made this a little bit longer. But anyway, it is acute because all of these angles are acute and none of the sides are exactly the same. All right, so this time we're going to do acute and isosceles, which is what we almost did over here. All right, so again, we're going to draw the baseline so that we can start our triangles. Okay, do you remember what the angle measures were on isosceles? Well, on an isosceles triangle, both of these angles are equal. Both of these are equal. And I don't think it matters what they are, but they both have to be equal. So I think what I'm going to do here is I'm going to make both of these angles I'm going to start with on this side. I'm going to make this one 50 degrees. So let's make a mark at 50. And I'm going to make this one, let's go ahead and draw that line. We may have to come back and do a little bit of erasing. That's okay. So that one's 50 degrees. And then let's come over here and make another angle from this side and make this one 50 degrees. Okay, so this one would be 50 degrees. And then let's connect these. Okay, now these two sides should be the same length. We'll have to double check. So now I'm just going to come back and erase these so they don't extend past each other. Okay, all right, now let's measure. So this one should be the longest. So this is 3.6. And then let's see if these other two sides are equal. Okay, so this side is 2.8 centimeters. So let's try this side. Yours may not be exactly 2.8 centimeters, but as long as they're close to being equal, that's fine. Okay, so this one is 2.8. Good. All right, so let's go ahead and label these with our tick marks to show that these are the same length. Okay, so this is the same length as this. Okay, so now we have constructed, or we have drawn 4 triangles based on given criteria. We were given 2 sets of characteristics. We were given side length, and we were also given angle length. Okay, so now for number 2, we have to draw on our triangles above. So I'm going to have to get rid of my protractor. It's in the way here. All right, so for number 2, it says, draw all possible lines of symmetry in the triangles above. Explain why some triangles do not have lines of symmetry. So let's think about this for a minute. Now, does this, if both of these sides are equal, if this is equal to this and both of these angles are equal, does this have a line of symmetry? Yes, it does. It has a line of symmetry right straight down the vertical middle. Now, that's not exactly equal, but I'll try to scoot it over. Okay, so this would be the line of symmetry. If you could cut this out and fold it in half, this side should match up to this side. Now, on this triangle, even though it almost has a line of symmetry right here, but technically, because this side is not the same length as this side, it cannot have a line of symmetry because this side would have to be exactly like this side. All right, so let's go back to A and B. All right, so for A and B, do you see any lines of symmetry? I do see one of these triangles has a line of symmetry. Can you figure out which one it is? Hopefully you said it was this one. If this side is equal to this side, then we should be able to draw a line of symmetry. See if you can figure out where the line of symmetry is before I tell you. Hopefully you thought right here. This would be the line of symmetry. Even though that's not, again, not perfect. I'm having a hard time with my lines today. So if this side is the same as this, if you folded it in half right down this line, they should match up. This does not have a line of symmetry because all of these sides are unequal, so they can't match up. Okay, so let's think about how we're going to answer this question. It says, explain why some triangles do not have lines of symmetry. Well, our triangles that did not have lines of symmetry were scalene, right? And the scalene triangles have 0 equal sides. So that has to do with why they don't have symmetry. So let's see if we can put that in a nice sentence. So let's say scalene triangles have no lines of symmetry because, what do you think would be a good way to end this? They have no equal sides. You can't match up 2 sides to be equal if you don't have any equal sides. Like this side was equal to this side, so I could make a line of symmetry right down the middle. But if there's no equal sides, then you can't have a line of symmetry. All right, let's look at the next page. Are the following statements true or false? Explain using pictures or words. If triangle ABC is an equilateral triangle, BC must be 2 centimeters, true or false? Well, first of all, we have to think back. What does it mean to be an equilateral triangle? Well, equilateral triangle, by definition, means that all 3 sides are equal. So, would line segment BC be 2 centimeters? If it's an equilateral triangle, this should be 1 centimeter, right? So, is this true or false? It's false, right? So let's say it is false because equilateral triangles have 3 equal sides. So that one can't be 2 centimeters. A triangle cannot have 1 obtuse angle and 1 right angle. True or false? I think this statement might be best proven with a picture. Okay, so let's try to make an obtuse angle. Okay, so let's go ahead and take a look at our protractor. Let's get our protractor here. And this doesn't have to be perfect, but let's at least make sure that we make a nice obtuse angle. Okay, so let's trace the bottom here. And let's make an obtuse angle. So let's make it 160 degrees. Okay, so let's put our mark there. And then let's use a straight edge to connect these two. So now we have an obtuse angle. So what if I tried to make a right angle here? Let's see what that would look like. I don't think it's going to make a triangle though, I can tell you that already. So if I took my protractor and I turned it like this, and I made a right angle right here, that's not going to be a triangle. Let's just go ahead and draw that because we're trying to illustrate this, right? All right, so there's that dot. All right, so let's connect that. I'm not going to go all the way to the dot this time because I don't want to cover up my words, so I'm just going to go towards the dot like that. All right, so let's try to make a 90-degree angle on the other side and see what happens. This isn't going to make a triangle either. Okay, so if I'm going to use 2 different colors here, okay? All right, so this would be if I connected this and tried to make a triangle. That doesn't make a triangle. And then if I used this, we'll use blue this time. If I tried to connect this to this, this doesn't make a triangle either. So if you have an obtuse angle and a right angle in the same figure, it always makes a figure that has 1, 2, 3, 4 sides, and the other one went 1, 2, 3, 4 sides. So a triangle cannot have 1 obtuse angle and 1 right angle. So I'm going to say this is true because a right angle and an obtuse angle make a 4-sided figure. Okay? All right, let's keep going. Triangle EFG can be described as a right triangle and an isosceles triangle. True or false? So remember, a right triangle means that it has a right angle. Does this have a right angle? So that part's true. And isosceles triangle. Isosceles triangles have 2 equal sides. So this side's equal and this side's equal. I can tell by the tick marks. So is this true or false? This is true. This is true because the triangle has 1 right angle and 2 equal sides. An equilateral triangle is isosceles. True or false? What do you think about that? An equilateral triangle is an isosceles triangle. Well, an equilateral triangle has 3 equal sides. And an isosceles triangle has at least 2 equal sides. So is an equilateral triangle an isosceles triangle? Let's draw a triangle here. You don't have to, you can freehand this, but let's go ahead and try to draw an equilateral triangle. So let's look at this for a second. So we have a triangle here, and this side and this side and this side are all equal. So it's equilateral, but it also has 2 equal sides. So can it be equilateral and isosceles at the same time? It can. So is an equilateral triangle is isosceles? Is that true or false? This is true because an equilateral triangle has 3 equal sides, and an isosceles, I always want to spell that wrong, triangle has at least 2 equal sides. Okay? All right, last part. This is an extension, so I want to see if you really understand. Triangle HIJ, A equals B. True or false? So if this side is equal to this side, are these angles equal? So let's think about that for a minute. If these 2 sides are equal, then this would be our line of symmetry. If that's our line of symmetry, then this angle is going to match up to that angle. So do those 2 angles equal each other? The answer to that is yes. It is true because the triangle has a vertical line of symmetry, which means angle A and angle B are equal. Okay, so today we really try to deepen our understanding about triangles. It's a lot to remember. So when you get ready to do your practice or you get ready to do your exit slip, you can always come back and look at your problem set to help you remember any of the information that you have forgotten.